Hello there. In video 12, we introduced a term that pertained to z-scores for groups. It was the standard error of the sampling distribution, or more commonly referred to the standard error of the mean, which we represented as sigma x bar, which was calculated as lowercase sigma, which is our standard deviation of the population, over the square root of n. Now, sometimes when we are looking at data sets, we won't have a standard deviation. A lot of older studies, going back 50, 60 or more years, reporting the standard deviation was not a common practice, and so we won't have this. However, variance, whether it's measured in standard deviations or as in changes in interquartile range or whatever measure of variance you use, is important in seeing how much the values move around, how spread out they are, how clumped together they are. And so we have a formula that we can use to substitute in for the standard error. Instead of sigma x bar, we're using s and x bar, which is equal to s over the square root of n. Now, this is a very similar formula. And really all we're doing is we're substituting the standard deviation, the unbiased standard deviation, so that corrected version of our standard deviation, for the standard deviation of our population, sigma, or lowercase sigma to be more specific. And so this fits into our formula for z-scores and is sometimes referred to as a large z-test. And here we're looking at z is equal to x bar minus mu over this term. However, this can be simplified to z is equal to x bar minus mu over this. These are equivalent terms. This is just a little bit more simplified, and you just have to remember what components make this up, whereas this shows you every single piece of information you need. Now, we could calculate this. However, this is the same idea as video 12, so if you need to see a calculation for this, go back, check out video 12, and you'll see how I calculate that. But whenever we see this term, substitute in this term, and you'll be golden. Well, I hope this helps you with your statistics and any research you might be doing or meta-analyses on older statistics, or even just for class, because sometimes we just need to know where these things come from for class. So until next time, cheers.